Hello everyone, welcome back to my channel. I am Nitya from Sri Venkateswara College of Engineering, Bangalore. In this video, I am gonna discuss briefly about the topic called probability distribution, which is related to the subject known as mathematics. Our concept is probability distribution and joint probability distribution. First, we shall know the introduction to probability distribution. Probability distribution is a mathematical function that describes likelihood of different outcomes of random experiment. It provides a way to quantify certainty and make predictions about the occurrence of the events. Probability distributions can be discrete or continuous depending on the nature of the random variable. Discrete probability distribution. Discrete probability distribution is applicable to random variables that can only taken in a finite or countable number of values. Examples of discrete probability distributions includes binomial distribution, Poisson's distribution, and geometric distribution. The probability mass function, that is known as PMF, is used to describe likelihood of each possible outcomes in a discrete distribution. Continuous probability distribution is used for random variables that can take any value within a given range. Examples of continuous probability distributions includes normal distribution, exponential distribution, and uniform distribution. The probability density function, PDF, it is used to describe the likelihood of different outcomes in a continuous distribution. Properties of probability distributions. Every probability distribution must satisfy certain properties including the domain, range, and up to 1. The mean, variance, and standard deviation are important statistical measures that helps to describe characteristics of a probability distribution. The shape of a distribution can be symmetric, skewed, or peaked, providing insights into the underlying data. Joint probability distribution. It deals with the simultaneous occurrence of multiple events or random variables. It provides information about the joint probabilities of different combinations of events. The joint probability distribution can be represented using joint probability mass function for a discrete variables or a joint probability density function for continuous variables. Marginal probability distribution. Marginal probability distribution focuses on the probabilities of individual events or random variables irrespective of their other variables. It is derived from the joint probability distribution by summing or integrating over the other variables. It provides insights into the probabilities of individual events occurring independently. Conditional probability distribution describes the probabilities of a specific event or random variable given the occurrence of another event or variable. It allows us to analyze the relationship between variables and make predictions based on observed information. Conditional probability distribution is computed by dividing the joint probability of the variable. Properties of joint probability distributions. Joint probability distributions must satisfy the same properties as individual probability distributions, such as normalization and non-negativity. The sum or integral of the joint probability distribution over all possible outcomes should be equal to 1. The covariance and correlation coefficients are important measures for analyzing the relationship between variables in a joint probability distribution. Here are some of the applications of probability distribution. Probability distributions are widely used in various fields including finance, statistics, and physics engineering. They are used for risk assessment, forecasting, decision making, and modeling complex systems. Joint probability distributions are particularly useful in multivariate analysis, data mining, and machine learning algorithms. Common probability distributions. Some common probability distributions include the binomial, Poisson, normal, and exponential, uniform, and chi-square distributions. Limitations and assumptions. Probability distributions are based on certain assumptions such as independence, randomness, and a fixed number of trials. In practice, these assumptions may not always hold true, leading to potential limitations and deviations from theoretical predictions. It is important to evaluate the appropriateness of the chosen probability distribution for a specific problem or dataset. Importance of probability distributions. Probability distributions provides a framework for understanding uncertainty, making predictions, and analyzing data. They helps in decision making, risk assessment, and hypothesis testing. Probability distributions are fundamental statistical inferences and can be used to estimate parameters and test hypotheses. Summary. Probability distribution describes the likelihood of different outcomes in a random experiment. Discrete probability distributions are applicable to finite or countable random variables, while continuous probability distributions are applied to variables within a range. Joint probability distribution deals with the simultaneous occurrence of the multiple events or variables, while marginal and conditional probability distributions focus on individual